In this video, you will learn how to solve systems of equations, or linear systems, by substitution. This goes along with section 7.2 in your textbook. Now let's recall a few important things we've learned over the past few days. A linear system, or system of equations, is a set of equations that has the same variables in them. Most of the systems we've been doing have two equations and two variables. A solution to a system of equations is an ordered pair that satisfies each equation in the system. This means that in a graph, this is where our two lines cross if it's a system that has one solution. And given the equations, we're looking for the xy pair that makes both equations true. Open your ISN to this foldable, and we're going to be working in the Solve a System of Equations by Substitution tab. This is what you should see on the inside of your foldable. By now we know how to solve an equation with one variable very successfully. But we have two equations with two variables, and we need to figure out how we can make this only one equation with one variable. So we'll follow the following steps. First, we'll isolate one of the variables, either x or y, in one of our equations so that we can substitute in our expression that has one variable into the other equations, giving us an equation with only one variable to solve for. After this, once we've found either our x or our y, we can use this value and put it back into one of the original equations in order to find the second part of our ordered pair. Let's try one together. So we have 4x plus 2y equals 7 and y equals 5x. This is nice because we've already isolated a variable. In this case, we've isolated y, and we know that y equals 5x. This means that instead of writing 4x plus 2y equals 7, I could rewrite this equation as 4x plus 2 times 5x, because we know that y is actually the same thing as 5x, equals 7. In other words, I took my 4x plus 2y equals 7, and instead of y, I wrote 5x because I know they're equivalent. Now I have an equation that I know how to solve, so you should draw the line and solve this equation. When we do this, we get 4x plus 10x equals 7, so 14x equals 7, and x equals 1/2. Now remember, we're always looking for a solution that's an ordered pair. So my answer is going to be x comma y, and I just found that my x is 1/2. That is not my final answer. I still have to solve for y. Because we're solving for a solution or an ordered pair that works in both equations, it does not matter which equation we substitute our x into to find our value for y. So I'm going to always choose whichever one's easier. In this case, y equals 5x is the easier equation to work with. So if x is 1/2, then I have y equals 5 times 1/2, or 5/2, which means that my final solution, or my answer to this problem, is 1/2, 5/2. So that would be the answer that you would write on a piece of paper. This means a few things. This means that if I were to graph the two lines, this is where they would cross. It also means that 1/2, 5/2 is a solution to both the equation y equals 5x and 4x plus 2y equals 7. And we should, of course, always check this. I would check this by taking my two original equations and substituting in my ordered pair xy to see if I get true equations. In my first equation, I get 2 plus 5 equals 7, which I know is true, which means that 1/2, 5/2 is in fact a solution to the equation. On the other equation, I get 5/2 equals 5/2, which also is true, which means that 1/2, 5/2 is a solution to that equation as well. Make sure that you always check your solutions and use parentheses to avoid making silly errors, so that you make sure that your ordered pair is a solution to both equations and not just one. It's very easy to make a small calculation error. At this point, we've completed learning the steps to solving an equation using substitution. The first step is to isolate a variable, and if it's already isolated for you, that's great. The second step is to substitute the expression for the second variable into the other equation. So in our case, since it was y that was already isolated, we had to substitute 5x into the first equation so that we could solve for x. Then we need to solve for our second variable by using whatever solution we got for our first, and we could substitute into any equation, and then write the solution as a point. Make sure you do that. You have to try these problems, they're problems 3 and 4, on the left-hand page in your notebook. If you feel comfortable, try them on your own. If you don't feel comfortable yet, watch as I do example 3, and then you can try example 4 on your own. Problem 3 is y equals 2x minus 1 and x plus 4y equals 23. In this system of equations, our first step is to isolate the variable. And notice that y is already isolated here, which is nice. So instead of y, we can replace our y with 2x minus 1. This means that I have x plus 4 times 2x minus 1 equals 23. Step 2 was to substitute the expression in for the second variable, and now I need to solve this equation. So I have x plus 8x minus 4 equals 23, which means I have 9x equals 27, and x equals 3. Now I need to solve for the second variable using x equals 3. You can substitute x equals 3 into either equation. I'm going to choose to do this for the first. Y equals 2 times 3 minus 1, or y equals 6 minus 1, so y equals 5. This means that my final solution, or the ordered pair, is 3, 5. That's my xy. And I, of course, want to check it, so I'm going to actually do it in my head. But it's always better to write it out. So I have y is 5, and I want to know if that's the same thing as my other side. 2 times 3 is 6, minus 1 is 5. So that one works. Now let's check the second one. X, or 3, plus 4 times 5, so 3 plus 20, equals 23. That works as well, so I know that it is in fact a solution. Try number 4 on your own, and we will talk about it tomorrow.